So hello and welcome to my first ever video blog. This is Sarah Thompson, aka Major Machines, and what we have here is an HP 3457A multimeter. It's not quite the Death Star of multimeters. It's maybe like an Imperial Star Destroyer thingy of multimeters. It's a pretty decent multimeter. I can probably think of some other Star Wars references, but being more of a Trekkie, I'll stay out of that one. Okay, so what do we have here is a piece of kit that I bought for the lab, only about 2-3 weeks ago. And it looked absolutely mint in the photographs, apart from a few little bits of writing on the front panel, which I'm sure you can actually make out here. So basically, we kind of had a little bit of an issue, and the person who packed it didn't do a very good job. And one of those lovely binding posts ended up missing its thing. So we are a thingless binding post. This is not good. So what are we going to do about it? The answer is I'm going to make a brand new one on the 3D printer. So this is going to be a bit of an episode involving some measuring and some 3D printing, and probably some more measuring and some more 3D printing, because I rarely get it right first time. And you're going to see a little bit of 3D CAD and all sorts of good fun stuff. Alrighty, so let's get going. So here's a closer look with the macro lens. So you can see that there's this thing that I'm rotating here, and that is actually a screw thread. So basically it's sort of a nut with a special thing on the outside, which seems to be to grip the insides of the plastic, which has now been destroyed. And we have another example of a perfectly okay one right here. I don't think it'll let me unscrew it. No, it's designed to be captive. That makes this a little bit tricky. So basically the way I'm going to have to do this is measure that fairly exactly, and then make a piece of make a new one of these that sort of pushes on and occupies the same space. This is going to make measuring a little bit interesting. So, alright, so what we need to do here is measure that properly and make sure that we do a decent job of the CAD. Alright, so let's start by firing up Geomagic Design 2014. Alright, so Geomagic starts up, and first thing we want to be doing is creating a thing. So let's create a thing. File, new thing, part. So basically I'm going to start here just by kind of sketching out the thing that we need to build. And once it's been sketched out, then I'll go back and work out all the dimensions. It's kind of nice working with Geomagic because it assumes this way of working. Alrighty, so the first thing we do is we select a plane, and then we go activate 2D sketch. And there we see we have a grid appears, and now we can start sketching. So basically what I want to do is sort of draw kind of a vertical cross section through the thing that we want to sweep to form a round thing. Sorry, I don't have the correct English for this. So the way we start is we just basically start by drawing some lines. So the top bit is going to be kind of there, and I'm sort of looking over my shoulder at the actual thing right now while I'm doing this, and click, sort of goes down a little bit, and then it goes out, and then it sort of stops, goes down a little bit more, comes in, and then I'm assuming probably goes all the way up to the top. Now, that little bitey ring thing at the bottom probably wants a little bit of relief, so I'm just going to do a little bit of magic here. I'm just going to draw a rectangle for that by 2 corners. Bam, bam, and then I'm going to go trim and cut out all the bits I don't want. So bang, 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 done. Now this has already created me a sketch that you can see has some things on here. That these little green things are actually called constraints, and what this basically means is with this kind of CAD software. Essentially you have a bit of magic in there called a constraint solver, and what it basically means is that I can move things around and it sort of remembers the geometry of the way I've created things and sort of makes a reasonable attempt at moving things around in a way that actually makes sense. Now this is very, very useful when you're doing, when you sort of start off a project and you're doing a design based on sketching. So I've just, literally all I've done here is I've just sketched the part that I want to make. If I tried to make something like this, it's probably going to be like 3 inches across, totally the wrong size. Doesn't really matter because the next thing I'm going to do is start constraining it. So the first thing I'm going to do is I'm going to take my trusty Multimeter calipers and I'm going to take one of these existing thingies and measure how deep it is. I don't necessarily care if I'm absolutely bang on, but that's kind of like, yeah, it's a bit of an angled measure, but I can do those, that's okay. So that's 6060, so 606 thousandths of an inch. And that is, if I get the standard dimension out, from that point to that point. And you see, if I point this in the right direction, I can actually put an angled measure on it. So click there and type in 0.606. Bang. And I just destroyed my diagram because I started at a very, very strange size. Great. So I've got a bit of moving around to do to fix these things. Not a big deal. We can deal with it. Much better, much better. Right. So another thing I might want to do is draw a construction line for where the center of revolution of this part's going to be. So I just do that there. There's a construction line. And that just gives me a visual and actual reference that I can use to actually do this design. Now, the first thing I'm going to do to start constraining this a little bit more is I'm going to work out what the diameter of the hole has to be. So here we go with the calipers. 0.3130. Let's try measuring it again, a couple of different places. 3330. Not a very good angle for this because of the camera, unfortunately. 3120. I'll call it 3120 because I want it to be a little bit on the tight side. All right, so let's do this. So 0.3120, and I need another standard dimension, and I need to go from there to there. And this is 0.3120. Ah, now wait, 3120 is the diameter. What I actually need is the radius. So with this system, I can actually put math in. I don't have to do the calculations. I can actually just tell it to do it. So that's a reasonable diameter. That's really quite large. It looks bigger than I thought it was going to. So the next thing I need to do is work out how big that little bitey thing is. I'm sure there's a technical term for it, not bitey thing, but I'm going to call it a bitey thing from now on. All right, so this is officially a bitey thing. Right, let's see how big you are, bitey thing. So a bitey thing is 3650 in diameter. Let's get it. All right, so standard dimension, there to there. 0.3650 divided by 2. This is starting to look right. And now I need to know how deep that thing is, which I may or may not be able to reach. Let me just try. Can I get in with it? This is going to have to be a bit of a guess because I can't quite reach. Yeah, call it 60 thou. Actually, it needs to not interfere, so I'm going to call it 100 thou. That's going to be safe. So, 0.1. There we go. Right, so we now have the inner part of this thing all fully sorted out. The next thing we need to do is to work out how big the outer side has to be. Now we already know what that dimension is, so that'll take care of itself. But I need to know what that diameter is and what that diameter is. So, simply enough, I measure it. But I'm going to measure it on one of the extant ones rather than the broken one. So the diameter of the top is 3720. So let's stick that in. .3720 divided by 2, as usual. Oh, that's kind of narrow. I might need to change that because that might be too narrow for 3D printing, but we'll see when we're done. And the next bit is to look around the base. I just want to make sure that's unplugged a little bit. .4465. All right, let's put that dimension in. Oops. I missed. I was on the wrong thing. So 0.4465 divided by 2 is that. Wow, those things are really skinny. It's no wonder it actually broke. Now this may be a problem for 3D printing, because 3D printing is not that good on really small things. So we have some unconstrained things yet. I'm actually just going to manually put a couple of dimensions in. So the length of that thing I'm going to put at 0.05, 50 thousandths of an inch. Sorry to all the metric people out there, I've been Americanized. Go shoot me. Which of course you can do with a gun that you can buy locally anywhere here. But no, actually don't shoot me, I'd be cross. I don't really like being shot very much. Alright, so let me see, what have we got here? Now one of the other useful things you can do with a constraint solver is it doesn't just do things like let you specify how big something is. You can also have it tell you how big it made something. So this particular dimension, I didn't give it that, it just calculated it. So that is 0.407, so that's 40 thousandths, and that's kind of a bit on the thin side. So I'm going to cheat a little bit, and this is not going to be a perfect match for the other knobs. It wouldn't be a perfect match anyway, but I'm going to fatten this up just to make sure that the thing prints right. So let's edit that. So that's 0.223 of an inch. Let me see. Perhaps I am going to turn the sound off on this thing because it just went bing bong. Where's the button for that? There we go. Sound is off. All right, so 0.22350, and I'm going to add. Now, what was that? 40 thousandths. I might make it twice that, so that makes it good and thick, and that's not going to break easily. So let's see what we can do with the top. I might have to do the same with the top. So let us edit this one too. And I'm going to add 40 thousandths to that one. Now bear in mind that this design is not going to be final unless I get very lucky first time. So the next thing I'm going to do is say, right, okay, finish with this sketch. I'm going to deactivate it. But before I do that, I actually want to align it with one of the existing axes. And you see that dot in the middle of the screen? That is actually the center of the X and Y axes. So that's X equals 0, Y equals 0. And what I really want to do is add a point on line constraint, which is this one here. And I want to go from that line to that point. And what that basically means is that this axis that I'm going to use to revolve the part is actually the y-axis, and that makes the next step much easier. Okay, so I'm going to deactivate the sketch, which turns it into just a drawing, and now with that sketch selected, I go revolve. And I'm going to revolve it through 360 degrees, and the axis will be the y-axis. Ta-da! Okay, bang! Ha! But you didn't think that was going to happen. Well, maybe you did. So that looks kind of like a knob, doesn't it? Surprisingly like a knob. So let's turn this into an actual piece of stuff. So what do we have to do for that? Well, what we have to do is fire up the 3D printer. Okay, so this is my Solidoodle 2 cheap and cheerful Kickstarter special 3D printer. So how do we get this thing fired up? Well, first thing we need to do is take our object, and we can't actually print it directly. We need to actually do something else. So, well, first thing I want to do is actually save the object itself, which would be quite a good idea. And it can join a few of the random things in this directory. What are we going to call it? This is a HP knob. Close enough. All right. So well, that's done its thing. Now I need to export that file, and I need to export it in a specific format, which is STL. And STL files are what are pretty much universally used by nearly all 3D printers to do their thing. So I'm about to export that. So the next thing I need to do is fire up the 3D printer software, which is this thing here. And we have Repetier host, Solidoodle version 0.85b. It's probably not the current version. I'm not very good at updating things. But here we go. So what do? First thing we do is we connect it to the printer. And it is connected. So we can look at the manual control thingy over here. And it starts returning telemetry, which is, these are important. This is the temperature of the extruder and the temperature of the print bed. So we don't necessarily care so much about the extruder temperature just yet. But we do care about the heated print bed. That needs to be hot, as does the extruder. So I'm going to turn them both on. And the next thing we have to do is wait for them to get hot, because there's not much we're going to print with cold stuff. Plastic only 3D prints when it's hot enough to melt, and it ain't going to print if it's not melting. So the first thing we have to do is wait for it to do that. Dum-de-dum-de-dum. Alright, in the meantime, I'm going to actually grab our object. So, this is the cool part. We've got add object, and here we have HP knob. Open. And it's a little on the small side, which is basically because this needs to be scaled, because the units that Repetier host are expecting in millimeters, and I designed it in inches. So I'm going to go 25.4, and other things on the side. So I need to guess wildly and guess correctly. So center the object, drop it, make sure it's in place. So now I can actually zoom in, take a close look, and that sure is the object we created. Woohoo! Isn't that cool? Now the first thing we need to do once we've got this is we need to slice it. 3D printers don't just print 3D. What they actually do is they actually take your object and they create it layer by layer, one piece at a time, one slice at a time, somewhat laboriously. So what I'm going to do is I'm going to go into the slicer page. This is my default setup that I usually use, nothing fancy here, and I'm going to tell it to slice. So, boom! 2 seconds, 3 seconds, 4 seconds, 5 seconds. Doesn't take very long for a small object like that. So what we have here, this is kind of interesting, we can actually see the code that has been generated by the thing that I just designed. So this sort of looks like the thing, and you can see that basically it's like you took my thing and then you recreated it out of little thin sausages. And that's literally what 3D printers do. They print sausages of plastic which are all joined together and glom together into the thing you want to make. So let's have a go at this and see what it does. So I'm going to go show single layer, which is kind of fun. And that basically lets you go through layer by layer and see what it's going to print. Isn't that neat? I just love that. I do that all the time when I'm designing prints. I just go backwards and forwards, backwards and forwards, backwards and forwards, backwards and forwards, backwards and forwards. I'm like a cat with a piece of tinfoil, really. Anyway, let's go back to manual control, see how the heating up's doing. All right, our extruder's at temperature. That's 212.1 centigrade, which is well enough to melt the ABS plastic that's fitted to this thing right now. But one of the problems with the Solidoodle is its heated print bed works just fine, but it takes for freaking ever to get hot enough to be usable. So by the magic of television, I'm going to speed everything up really, really quickly. Okay, so now, as you can probably see, the extruder is sort of, now that it's up to temperature, it's sort of gradually leaking plastic. So let me see if I can just reach in there and just pull that out. So, yeah. So typically you'll see me reaching in there and pulling stuff out of it every so often. It's a bit difficult to do with a big camera in the way, but I'll manage. For some reason this printer sort of oozes plastic. Let me see if I can grab that. There we go. Still only 62 centigrade. Boring. I sometimes fantasize about getting my hot air soldering gear and just sort of like pointing it at the bed to heat it up faster, but can I be bothered? No, not really. So I don't know if you can see it on the film, but naked eye I can actually see a little bit of flicker in the lights that are inside the Solidoodle box, and I suspect that's because it's busy dumping as much current as it possibly can into the heater. So that's what's going on there, I think. Just as an aside, these cheap-ass bent nose tweezers that you can pick up off eBay for a couple of bucks are absolutely fantastic for dealing with 3D printers. You can actually lever things up off the bed with them. You can grab plastic with them. You can actually pull parts off with them. So anyway, we'll come on to that later. Okay, now we're almost up to temperature, so I'm just going to give that nozzle one last little clean. And I'm going to tell it to run the job. Just click run job. Ooh, it's doing things. That's so cool. So to adjust the focus a little bit. So what it's doing here is it's actually going in circles, just getting the plastic started coming out of the nozzle. You can see it's starting to come out, and it's sort of not in a really very good state. It's kind of going everywhere. I'm going to have to reach in and just pull that out, so it's not going to work very well. I don't know if fancier 3D printers get around this at all, but Solidoodle's a pig for this. There's a big lump on the head, let's see if I can get rid of that. There you go. Alright, now it's going to start the actual print. So the interesting sound effects you can hear here are actually the stepper motors driving the head around. Cool noise, isn't it? Now one thing you'll notice is that it went all the way up to 92 centigrade to get the first layer to stick, but the temperature has now gone down to 83 centigrade, and I forget what it is set to stabilize to, but the basic idea is that you really want the first layer with the bed nice and hot so that it sticks, but you don't want it to stay that hot because then it sort of distorts and the edge curls. So you really want to cool the bed down after that, but not too much, because if you cool it too much it'll pop off. But okay, so here's the thing going. So as you can see, we are now on layer 9 of 50, layer 10 of 50. So this is motoring, it's going fairly quickly. And it thinks we have about another 7 minutes to go, which is probably accurate. Just past the halfway point, layer 27 of 50. This is exciting. You can see as we're getting closer to the top that these walls are actually kind of thin even now, so if I'd actually used the wall thickness of the originals, I don't think this would have actually held up and it probably would have fallen apart. And we're done! So now what we need to do is part that from the table. Now for the final one, this is probably not going to be the final one we make. I wouldn't just rip it off the table because at this point I want to keep the print bed nice and hot so that it won't take long to get back up to temperature for the next one. But to keep perfect dimensional stability, I wouldn't normally do that. So let's get rid of that nasty thing. There we go. Okay, so let's see if this thing fits. Probably won't. That's tight. No, too tight. So, yeah, unfortunately the hole there is just a little bit too small. Now one thing that's interesting is that little ridge that I made for the bitey thing will go over just nicely, so I know the size is close. Let me try the other end. Nah, it's just a little bit too small. So let's try the calipers on here. So let's remind ourselves what the size was. So that was 3120, and we want to look inside, so 2925. Ooh. Okay. So 3120 minus 2925 means we are a whole 195 thousandths of an inch too small. This is not good. This is not going to remotely fit. So we need to make some modifications to the design and repeat. All right, let's do this thing. So 195, I'm going to remember that. I'm going to keep that handy because I have no memory for numbers whatsoever. Okay, here we go. Back into our CAD system. Now one of the other nice things about this kind of CAD is it makes it very easy to modify things. So basically I can go back to the original sketch, tell it to edit, and there we are. Isn't that lovely? So right, we know that this dimension here to this dimension here is probably correct. You know, the length of that is probably correct. So what I'm actually going to do is I'm going to stick a dimension line. Actually, no, what I'm going to do first is I'm going to delete this dimension line, which will leave that where it was. And I'm going to create a dimension line which just dimensions this. So that dimension's relative. And I'm not going to change that, that's just going to be as it is. Now, it is, where is the dimension? It's this 0.156 that's a problem. So what do I need to change that by? Now to make it exactly equal, I'd need to change it by half this. So let's go half of that. So that's 39 thousandths of an inch. That needs to go wider by 39 thousandths. I don't want to make it 39 thousandths wider because I want interference fit. So I want to actually have to push the thing on so that it stays put. I don't want to glue it. So what do we want for an interference fit with plastic? 5 thousandths is probably fine. So let's take 5 thousandths aside. 5 thousandths aside is safe. Okay. Whoops. Was that 39? Minus 5 thousandths aside is 34 thousandths of an inch. So basically this measure is 34 thousandths of an inch too small. So let's edit it and tell it to increase by 0.034. Boom. Now that wasn't good. That's not what I wanted. Let's change that back. So what the problem we have here is that all these dimensions that I made originally are all relative to the center line. I don't want them to be, so I'm just going to delete them. And I don't delete that one too. And I'm just going to create new ones that lock them in place, basically. There we go. So now, when I increase this by 34 thousandths of an inch, oops. So now, when I increase this by 34 thousandths of an inch, that's more like it. All right. If I'd thought of that first, that would have been better. Now, when I deactivate the sketch, you'll see what happens. Aha, it remembered that I'd turned it into a surface revolution. So there's version 2. So let's save that. As before, export it to the 3D printer as an STL file. I'm going to call it HP-knob2. Go into Repetier, back to object placement. And now we can actually, there is an option to quickly do this. What I need to do is remove the object and add a new one, which is HP-knob2. Open. Usual problem again. 25. Whoops. There. 25.4. 90. Now another thing you kind of want to do with 3D printers is try and keep it consistent. So I'm going to center it to a drop. The reason I do that is that there can be a little bit of variation across the bed on the 3D printer, both in terms of temperature and in terms of dimensions. So if you're going to do this sort of thing where you make a part as a prototype and then measure it and then modify it and then reprint it, it really behooves you to do this very carefully and make sure that you keep as many things the same as you possibly can. Alright, so I'm going to go back to manual control. Print bed is kind of too cold now, but it doesn't really matter. I'm just going to hit oh, I forgot to slice it. Oops, that would have been bad. I just printed another copy of the old one. Slice. Done. Oh, you see it got thicker. Yes. And manual control. I don't know why it was so far out. I may have just measured it wrong or whatever, but hey, whatever, you know, life goes on. No point shooting yourself for these things. Okay, manual control, run job. Here we are again, waiting for the 3D printer to warm up. So we're at 86.6 centigrade, waiting for it to go to 92. And I've got my tweezers at the ready to clean up the head as soon as it starts going. So here goes, pretty soon. We should have some action. It's so exciting, I can barely contain myself. Ah! One thing you may notice the 3D printer doing is that it goes much faster on internal stuff than it does on external edges. That's a little tweak I made to the settings, which just improves the surface finish on parts. I mean, the surface finish on a lot of these parts is not that fantastic, but it's good enough for the job for this sort of thing. too big, I think. Yeah. Oh crap. Oh dear. I just totally made a complete ass of that. Oh, that's actually it. Oh! Did I add that to the wrong dimension? Because that's a good fit. Not a terrible fit for the grabby thing now. Okay. Gives me something to work with. Right. Okay. Let's try that again. Okie dokie. Back to the drawing board, almost literally. Right, here we go. Back to the drawing. Edit that. Bang. There we go. So we have this thing that's too big, but we know that this part here is where this part should be. Now that's fascinating. So I bet I put the dimension in the wrong place. So let's see. So that is 190. Now if I delete that and create a dimension, I thought I looked wrong. .190 there. Ka-chunk. Yeah, maybe. Try it. Shall I? Yeah, whatever. Alright, deactivate sketch. Save the thing. Export the thing. Call it m0mV3. Done. Open up Repetier. Object placement. Remove object. Add object. m0mV3. Wrong size. 25.4. Boom. 90. Sorted. Center. Drop. Slicer. Slice it. And looks good. So back to manual control. Run job. Here we go. Okay, and like Flynn, as Dave on EV blog would say, to grab this little bit of schmutz. Go and get it. There we go. Just while we're waiting for this to print, I just thought I'd show you the cool thing that you can actually do by just zooming in, and you can actually see that the simulation shows the thing actually printing the plastic, and the colour represents the temperature, so it simulates the plastic cooling down as it's deposited. I think that's cool. Alrighty, here we go again. Alright, so I'm going to try, even though this is a little bit too hot to handle, to shove it on while it's still hot. Because if I can pull that off, it'll cool and jam itself in place. Oh, I think we might have it. I think we've got it. Oh yeah. Yep, that'll do the trick. Right, only other thing I need to do is find some kind of plug to shove in it to make sure it actually still works. Alright, so just some random plug. Goes in there just fine, no problem at all. Bob's the jobby. And because I jammed that on there while it was still hot, that is as solid as you could get gluing it. Proper good old interference fit. Sorry about the lighting on this. I've only got one light in here because I've got or rather I couldn't get another light in the other side because there's equipment in the way. Hopefully when the lab move is done in a couple of weeks that'll be sorted. So yeah, it's fixed. Yay, we're done, we're done. So just out of interest, I thought one or two of you might wonder if I've done this before, and yes, in fact I have. If you look at those natty little black knobs on my beloved LeCroy 9370M, which currently isn't working, which needs fixing, so that's probably going to be the next episode. So when I got it, it was missing a few knobs. Not only that, the actual shaft encoders were broken, so I popped those out, replaced them, and well, knobs are a bit difficult to come by that still actually fit this thing, and the commercial ones didn't quite fit right, so my first knob replacement with a 3D printer was in fact this thing. So if you can see, there's actually 1, 2, 3, 4, 5 black knobs on there which work beautifully and have seen me in great stead for a little while. Alright, so that's the end of the show for today. Please subscribe if you're interested in seeing more stuff like this, or just because you like me. I mean, well, if you don't like me, you can subscribe anyway, just to make sure that you know that stuff's coming out and you can actually watch it and make sure that you don't like it, because you never know, you might actually start liking it. Well, you never can tell. But anyway, so like my video, give me a thumbs up, give me a thumbs down, I mean, whatever. I mean, bad reaction's better than no reaction, someone much cooler than me once said. Alright, thank you. See you again soon. Bye-bye.